this is the more exciting stoichiometry problems. The first step is acetic acid. There's 3 ways of writing acetic acid. We realized that before we were videotaping. Okay, aluminum hydroxide. Aluminum's +3, hydroxide's -1. So what's the formula going to be for that? It's going to take... Go ahead.
Oh, wait, I don't know.
Well, if I said 3 pluses and I want to put it together with OH minus, that's only 1 minus. So 1 OH minus is going to take care of 1.
Yeah, then there's going to be 2 at the top or something.
Something like that. Not quite.
Okay.
All right. That's okay. Now, that's how we learn. If this thing here has 3 pluses, how many minuses am I going to need to get that to cancel out?
2 more.
2 more. So I'm going to need, here's 1 OH, here's another OH, and here's another OH. Right?
Right.
So I'm going to need not 1, not 2, but I'm going to need 3.
Oh.
Okay? And so we would need Al. We only need 1 of those, but we need 3 of the other things. So we write the subscript to say that there are 3 of them, and we put it in parentheses to say that that there's 3 of the whole thing. This thing, there's a fancy name for that. Quick review. It's called a polyatomic ion. But that's a big word, but what does it really mean? What's poly mean?
Many.
Many. Atom. Ion. There's too much glare. You really can't see that. I have to adjust my lighting. Okay. So that's the first 2. So this is not simple. This is a lot of chemistry in this one problem. So if we go Al parentheses OH parentheses 3. Now, what's it make? Makes water. Well, I think I can do water. Water's pretty easy. What's water?
H2O.
H2O. Or I'm going to write it another way. And you'll see why here in a minute. I'm going to write it as HOH. Same thing, right? Am I off screen?
Oh, you're fine.
Okay. Okay, HOH. And then it says aluminum acetate. Well, heck, that's a lot of things we got to know. We got to know what the acetate ion is. Well, here's the deal. This whole thing is acetic acid. When it loses its H, what's left behind is the acetate ion. CH3COO. Okay. And that's going to be hooked to aluminum because the last piece of the problem says, and aluminum acetate. Okay. So let's go and do like we did before. We said aluminum hydroxide. Aluminum is +3. Hydroxide's -1. So we're going to need 3 hydroxides to react with the aluminum. Well, same drill here. If aluminum is 3+, and acetate, am I still on screen?
Now. Yeah, you're good now.
Aluminum's +3, acetate's -1. We're going to need 3 of these to react with one of those. Is everybody good with that? So this is going to be Al parentheses CH3COO parentheses 3. Let's look at a couple of things. Over here, remember balancing? Balancing shouldn't be too terrible goodness awful, right? Okay, so if you look over here, there's an acetate ion. And you look over here, there's 3 acetate ions. Okay. You look over here, there's an aluminum. And over here, there's an aluminum. Okay. So the way I used to do, I always teach balancing looks like this. We look at what's on each side. We've got C2H3O2 minus. We've got hydrogen. We've got aluminum. This is a tough one to start off with balancing. So if balancing's out of your league or it's not something that you remember well, let's do a few easy balancing problems first. But
Okay.
I'll just show you this one while we're here. Okay, so if I look, I'm going to do a count. I'm going to say how many of each of these things on each side. I see 1 over here. Pen's not working. And I see 3 over here. I see 1 hydrogen over here. And I see 1 hydrogen over here. I see 1 aluminum over here. And I see 1 aluminum over here. I see 3 hydroxides over here. And I see only 1 hydroxide over here. Now, does everybody see where I'm getting those numbers? Now, to fix all this, what we need to do is we need to make there be the same number of everything on both sides. Since there's 3 of these over here, we need to make there be 3 of them over here. So we're going to multiply this whole thing by 3. Because you can't change what's reacting. We said it's acetic acid and this reacting with that and that. So we need to make there be 3 of that whole thing. So that's going to change the acetates to 3, but it's also going to change the hydrogens to 3. Then we look and we see 3 hydroxides over here, but we only have 1 hydroxide over here. Now this speaks to why I made it HOH instead of H2O, because we're counting H's and we're counting OH's. And I just counted that there were 3 H's over here, and now there's only 1 H plus over here. There's 3 hydroxides over here, but there's only 1 hydroxide over here. Now, to fix that, what I'm going to do is I'm going to go, okay, I've got 3 hydrogen over here and only 1, 3 hydroxides over here and only 1. So I'm going to use a 3 waters. I'm going to move that. That's an arrow. You can tell my art stinks. Okay, and there's 3 there. So now there's 3 hydrogen and 3 hydroxide. And you'll notice on both sides, we've got the same amount of everything. We've got 3 acetates, 3 acetates, 3 hydrogen, 1 aluminum, 3 hydroxide, 3 hydroxide. So now we've got a balanced reaction, and now we can actually do the chemistry.